Hi, my name is Ashley. I have the ln of x function. The ln(x) function has the following characteristics. ln(x's) domain is x greater than 0. This means that x can't be 0 or negatives. So if this is the x axis, you see it's just going up. ln of x's range is y equals all real numbers. So this is y axis. It's going down, so it can be all real numbers. The x-intercept is 1, 0, which you can see right here. And there is no y-intercept because this is an asymptote, so ln of x never touches the axis. The ln(x) function increases in all x values. So as you can see, it's increasing. It's going up, the x values. However, the function does not decrease. As you can see, ln of x concaves down, meaning here it goes down. And the asymptote is the x-axis. So, yeah. Transformations. The first ones I'm doing are translations, and we'll be moving the graph up first. For translations, the graph can either move up and down and or right and left depending on what numbers you use and where you place them. This is the first example. Here's the regular graph of ln of x, and then this is ln of x moving up 4. So as you can see, here it is regularly, and then it's moved up, and it never touches the axis even as much as it looks like it might. So if we want to move it down, move the graph down, you just subtract 4. You put the 4 in the same place it was here, but you subtract, and it moves it down. So this is the regular ln of x graph, and this is moving it down 4. Translations, moving the graph to the right or left, is basically the same kind of, you're doing the same basic thing, but you're putting the numbers in different spots. So for example, this is the regular ln of x graph, and then here you're moving it to the right. One thing about moving it to the right or the left, you might think you would add to move to the right, but you actually subtract. So to move to the ln of x function to the right, you do ln of x minus 4 in parentheses. If you want to move it to the left, you do the same thing, but like I said, you add 4 if you want to move to the left. So here's the regular graph, and then here's moved to the left. So as you can see, it really did move to the left. Now for flips, you'll need to place a negative somewhere on the function. It's important to remember that if you want to flip the graph vertically, then place the negative sign in front of the entire function. If you want to flip the graph horizontally, place the negative sign in front of the x. So first we're going to move it vertically. Here's the regular function graph, ln of x. Here we're moving it vertically. That means we've put the negative sign in front of the entire equation, which moves it vertically. So yeah. Now we're moving it horizontally, which means that we're placing the negative sign right in front of the x. So when you want to move something horizontally, you place the negative sign right in front of the x. So here's the normal ln of x function graph. And here's when we moved it horizontally. So as you can see, horizontally means the y-axis. So here's the y-axis, and it's flipped over the y-axis. Now we're at inverse. E to the x power is the inverse of ln of x, and vice versa when they flip over the graph y equals x. So if here is the line y equals x, this is roughly what y equals ln of x would look like. And this is roughly what y equals e to the x power would look like. And so it's an inverse because they basically flip over y equals x and they kind of reflect each other. They look like each other. So